Particle P moves with constant acceleration 2I minus 3j meters per second squared. At time t equals 0, the particle is at the point A and is moving with velocity minus I plus 4j meters per second. At time t equals capital T seconds, P is moving in the direction of vector 3I minus 4j. Part A wants us to find the value of t. So the first thing we want to do for this question is find an expression for the velocity of P. And the reason for this is because we're told at time capital T seconds, P is moving in the direction of this vector 3I minus 4j. And what this means is that it's parallel to this vector. And this means that its velocity is some multiple of 3I minus 4j. It doesn't have to be exactly 3I minus 4j, but it has to be some multiple of it because it's moving parallel. That's just a general rule with vectors. So to find the velocity of the particle P, and we've got the expression for acceleration, we know as a general rule that the acceleration of particle P is equal to the derivative of the velocity. And therefore, if we reverse this, we know that velocity must be the integral of acceleration, which is 2I minus 3j, and then this is dt. So if we were to integrate, we can just write this as 2ti minus 3tj, because if we treat 2i as 2t to the power of 0, we add 1 to the power, so we get 2t to the power of 1, and then divide the coefficient of t, which is 2, by this power. 2 divided by 1 is 2, so we're left with 2t. And we do the exact same thing for minus 3j, and we get minus 3tj. And then because this is indefinite integration, we have to add a constant plus c, which in this case is also a vector. So now we want to find what c is, so we can get a complete expression for velocity, because this isn't quite complete because we don't know what c is. To find c, we can use some more information we're told in the question, which is that at time t equals 0, the particle is moving with velocity minus I plus 4j meters per second. So we can say that when time is equal to 0, this expression here, so where we replace t with 0, should be equal to minus I plus 4j. And given that this term here and this term here both go to 0 because they're all multiplied by 0, we know that c is equal to minus I plus 4j. And therefore, if we were to write the full expression for velocity, and if we also factorise the I terms and the j terms just to kind of keep them together, because it tends to be easier to work with them like that, we get that 2t minus 1i plus 4 minus 3tj is our expression for the velocity of particle P. So now we have this complete expression. We know that at time t equals capital T seconds, P is moving in the direction of the vector 3i minus 4j. And in the direction implies, as I said previously, that it's parallel. And given that parallel means that it has to be a multiple of this vector 3i minus 4j, we can write this as lambda, where lambda is just an unknown that we need to work out, multiplied by this, which we can then expand to 3 lambda I minus 4 lambda j. And therefore, if we say that at time t equals capital T seconds, the velocity is equal to this 3 lambda I minus 4 lambda j, we can actually solve for t. So if we say that when t is equal to capital T, and then we write out this whole expression, but we replace t with capital T, and then this is all equal to 3 lambda I minus 4 lambda j. Now what we know now is that we can do something called comparing coefficients, which is that the coefficient of I on the left hand side, 2t minus I, has to be equal to the coefficient of I on the right hand side, which is 3 lambda. And it's the exact same for j, so 4 minus 3t has to be equal to minus 4 lambda. So if we write out these two expressions, we can actually solve to find t. So if 2t minus 1 has to be equal to 3 lambda, and 4 minus 3t has to be equal to minus 4 lambda. If we rearrange both of these, where lambda is the subject, so over with this one, we have that lambda is equal to 2t minus 1 divided by 3, if we just divide both sides by 3. And here, lambda is equal to minus 4 minus 3t all over 4, if we divide by minus 4. We now have two expressions that both have lambda equals at the start of them, which means that we can set, if we call this equation 1 and this equation 2, we can set equation 1 equal to equation 2. So if 2t minus 1 is equal, divided by 3, is equal to minus, and if we expand out this bracket on the top, minus 4 plus 3t divided by 4, if we multiply both sides by 4 and then multiply both sides by 3 to get rid of these two denominators, we're left with 4 bracket 2t minus 1 is equal to 3 bracket minus 4 plus 3t. And when we expand these out, we're left with 8t minus 4 is equal to minus 12 plus 9t. And now if we take away 8t from both sides and add 12 to both sides, we get that t is equal to 8. And that's our answer. And there are 4 marks available for this question. Mark number 1 is a method mark, and it comes from finding this first expression for velocity that involves a c term. And then we get an answer mark for finding this c term and therefore stating that this over here is the whole expression for velocity, 2t minus 1I plus 4 minus 3tj. And then we get a method mark for doing this equation over here, so we find both equations in terms of lambda and set them equal to each other as a simultaneous equation. It gets us a method mark. And finally, we get an answer mark for finding that t is equal to 8. At time t equals 4 seconds, p is at the point B. Part B wants us to find the distance AB. So because we wanted to find the distance, this means that we know we're talking in terms of displacement. And the general rule with displacement is that velocity is equal to the derivative of displacement. And we have an expression for velocity that we found in part A, which means we can find displacement. So if we reverse this, it means that displacement is equal to the integral of velocity. And our expression for velocity was 2t minus 1I plus 4 minus 3tj dt. And if we integrate this, we get that this is equal to t squared, because we add 1 to the power, and then we divide the coefficient of t by that power, and 2 divided by 2 is 1, so we have t squared, and then we use that exact same method for all of the other numbers, and we're left with this. And we have to remember that there is a constant vector that we can call d, just because we used c in the previous part, that we have to add on. However, if we assume, we're told earlier, we were told that point A is when t is equal to 0. And if we make the assumption that therefore displacement is also equal to 0 at this point, it makes the calculation a bit easier. And that means that if when t is equal to 0, s is equal to 0, then if we substitute all that into our equation down here for displacement, then this actually means that d is equal to 0 too. And that makes it a lot easier, as we now have a full expression for the displacement, which is t squared minus ti plus 4t minus 3 over 2t squared j. So now we have our expression for displacement. We can find out what the displacement is at time t equals 4 seconds, because that's where point B is. So if we say that when t is equal to 4, and then we substitute in the numbers, 4 squared minus 4i plus 4 multiplied by 4 minus 3 over 2 4 squared j is actually equal to 12i minus 8j. So the displacement at the point B is 12i minus 8j. So if we were to draw a rough sketch of the points A and B, so if we say A is here, and we treat this as t equals 0, s equals 0, then from that, if point B is 12i, this means that it's 12 to the right, 12 along in the positive direction from A. And then minus 8j means that it is then 8 downwards in the negative j direction. So that means that it's 12 along and 8 down, and this is the point B when t is equal to 4. And that means that if we were to find the length of AB, we can just use Pythagoras' theorem, because we know these two lengths here, and this is a right angled triangle. So if we were to use Pythagoras' theorem to find the length AB, we would get that AB is equal to the root of 12 squared plus 8 squared, which actually is 4 root 13. And that is our length of AB. So we can say that the distance AB is equal to 4 root 13, and if we want to add a unit on, it's 4 root 13 metres. And there are 4 marks available for this question. Mark number 1 comes from integrating the equation for velocity to find an equation for the displacement, which we've done up here. And then we get a further answer mark for actually getting this correct. So we actually get 2 marks for integrating s. So just doing it at all and then getting the correct numbers that they have in the mark scheme. Thirdly, we get a method mark for using Pythagoras' theorem to find the length AB, which is what we've done here, doing the root of 12 squared plus 8 squared. And finally, we have an answer mark for finding that this is the distance, 4 root 13 metres.